Please welcome to the stage founder and CEO via Nice Systems, Inc., Dr. Vishal Sikka.
Good afternoon. Wow, full house here. I want to talk to you about AI. It's one of the most hyped words of recent times. And I want to talk to you about how we can bring AI to the enterprise in a very big way. So let's dive right in. We have all seen and heard about some really impressive achievements in AI in the recent years. I have a few examples here, some of these. Up there you see a automated valet parking, a level 4 autonomy for valet parking system that was launched by Bosch and Daimler last month. And facial recognition technology, you see a little video playing there, has reached quite a maturity where in real time we can detect sentiments and facial expressions and so forth. Healthcare is an area where some enormous applications of AI technology are possible. Just last week, GE got clearance from the FDA to put a system which integrates AI into an X-ray system. And also, a couple of weeks ago, earlier this month, one of the systems built by the Allen Institute for AI passed an 8th grade science test for the first time. Right there in the middle, you see today's SQUAD leaderboard. SQUAD is the Stanford question answering data set. And it's basically SAT-like questions. Actually, it is significantly simpler and more primitive than the SAT type questions. SQUAD 2.0 is because the systems now also answer questions whose answers are not in the paragraph that they give you. But you can see that the human performance up there, it's a little bit too small, but you can go to the Stanford website and check it out. The human performance is up there on the first row, and the first 6 systems as of today are beating human performance on both of those tests. 4 of the systems are listed where they are from, 2 are anonymous. All 4 systems that are beating it that are listed are from China. And most of the recent news in AI has been led by the advance in one particular branch of AI, one particular branch of machine learning with deep neural networks. And the 3 pioneers of this deep learning age of neural networks, Yoshua Bengio, Jeff Hinton, and Yann LeCun, won this year's Turing Award, which is the highest award in computer science. So we can see that AI is having this is just a small glimpse. There are 45 papers in the machine learning topic that are published on arXiv every single day. So when I was a PhD student, you were required to keep up with your field. It is pretty much impossible for someone to keep up with the field now because there are 45 academic papers that are published every day, including on the weekends. So huge advances, and you can clearly see that this is a very powerful technology. But at the same time, there are some massive issues, unresolved issues. Here is a smattering of those. Right in the middle, there is a turtle, which one of the Google systems famously thought was a rifle. For whatever reason, that turtle looked like a rifle to it. And fortunately, it wasn't one of these weapon systems that saw it from outer space and tried to shoot it down or something. And that poor turtle, maybe in a zoo or something. That picture of the Uber crash that everybody heard about, deep fakes. There is a famous video out there of a picture of Jennifer Lawrence accepting a speech or talking about something where live while she's speaking, it gets morphed into this other guy. I think that is Steve Buscemi, his face, and the speech continues. And this deep fake stuff is actually quite real. Recently, I think just about 3 or 4 weeks ago, there was a famous, notorious case of people who faked the voice of a CEO and committed some cyber crimes. More seriously, the bias problem in AI currently is a very serious one. On the bottom left, you see a study done by the National Institute for Science and Technology, which examined not one, but majority of the big facial recognition systems. And they found that the best algorithms that are out there have a significant bias. In this particular case, they are 5 to 10 times more biased against black people. And the orange bars that you see on those graphs, they are all the graphs for the black women applicants to jobs. And more tellingly, there was a study done that showed that by putting markers in particular places, you could fool an autopilot system. And also last month, one of the medical journals published, you might have heard about a study where one of these AI systems did extraordinarily well in identifying cancer in radiology images, better than radiologists. It turned out that in this particular case, the system was in fact zooming in on some markers in the pictures. And the markers, it turned out, were placed by doctors who suspected that there was cancer in those pictures. So inadvertently, the neural network had settled in on those pictures where there were those markers there already. And when they randomly distributed the markers, then the accuracy came down significantly. And there's a very significant reason there. The neural networks are incredibly powerful perceptual apparatuses, but they are not, they don't have a sense of meaning of what cancer is or what a marker is. And they are really great at digesting massive amounts of information that has already been labeled and then making predictions and perceptions based on that. And when we look at the state of AI in the enterprise, there is a bunch of words that come to my mind. The first one is fragmentation. We are towards the end. Last year's Turing Awards winners were David Patterson and John Hennessy, who did pioneering work in silicon manufacturing. And their main point was, their main observation was that Moore's law is more or less coming to an end. And what we are in the age now is of domain-specific architectures. So specialized chips, custom silicon. And I have a few pictures there. You see the green box in the middle is Google's TPU, the tensor processing unit. That's the third iteration of the TPU. And the Tesla's latest GPU is on that left-hand side. Tesla, the car company, is making its own chip as well. There are several startups. There is a chip from GraphCore up there with the colored boxes. And this big golden box that you see on the bottom right, that is a wafer-scale chip for AI built by a startup called Cerebras. And then above that is the Ascend 910 from Huawei, which is, according to them, the most powerful AI processor in the world right now. So you can imagine that at the very foundation where our industry stands, where the processors are, there's also the picture of the A13 chip from Apple, which is in the iPhones. All major companies have their own AI chips. And so you can imagine that the times that we are entering into is one where the very foundation has this deep fragmentation. Everyone has their own silicon. And some of that fragmentation makes its way into the software layers as well. There are large numbers of frameworks and tools for building AI systems. In general, at an enterprise, at an infrastructure level, software is getting fragmented. The developer experience of building an AI system is quite badly broken today. And we'll talk about that in more detail later on. And then, of course, when you think about services, perhaps the impact of this is the most stark, the most profound. IBM did a study last year, no, not last year, last month, which said that 120 million workers will need to be retrained because of AI. Kai-Fu Lee, in his book, famously talked about AI killing half of world's jobs within the next generation. And on the other hand, the number of AI engineers is actually quite small. Tencent did a study that says that the number of machine learning engineers, people who can build, who can use TensorFlow or PyTorch or Keras or something and build an AI application, that number is in the neighborhood of 300,000, maybe around 500,000. But the number of people who could explain an algorithm to you, who could make changes to an algorithm, that number is much smaller. It is in the neighborhood of 20,000. And those 20,000 people, of course, there are ridiculous salaries and they get hired by the big companies. That box on the bottom left that you see shows the hyperscale clouds CapEx. The tallest graph is from Q4 of 2018. That is the quarterly spend by the hyperscalers them alone. It's more than $30 billion in one quarter in CapEx. $30 billion between 5 or 6 companies. So when I look at the AI situation overall, it is a situation where, on the one hand, there are some incredibly powerful applications that can be built across the board, in every industry, for every kind of business process. And yet, there are these massive issues and asymmetries. So when we go to the history of AI is a very old field. It has been around since 1956 at least. John McCarthy, that you see up there, was the father of AI. He wrote a paper when machine learning was starting to become popular in 1997. He said that machine learning research has focused on appearances and not on the reality behind the appearance. And to show that, he made a beautiful puzzle, which was 2 disks. One disk said the word horses, the other disk said the word elephants. And then they were put on top of each other so that part of horses always obstructed elephants and part of elephants always obstructed horses. But if you spun those around, and he made a little Java applet for it back in 1997 to prove this point, that a 4-year-old looking at those disks could tell that there is horses and elephants written there. But it doesn't matter that by recognizing the pictures, you can recognize the word unless you understand the phenomenon underneath that is causing that thing to happen. And that causality, that underlying deeper point of AI, was made even more tellingly by Udaya Pearl, who is the other gentleman that you see there, also a Turing Award winner, who talked about all the impressive achievements. This was his statement last year, that all the impressive achievements amount to curve fitting, that's fitting a model that fits into a curve around the data. So we need more in order to get to better intelligence, more sensible intelligence, more reliable intelligent systems. We need to go make significantly more progress. Daniel Kahneman wrote about thinking fast and slow. If we look at our own brains, we realize that we have a fast thinking apparatus. If there was a loud noise, we would all react to it and so forth. And that is similar to the neural networks that we have today. But we also have a slow thinking apparatus in the same brain of ours, where we can express things and reason about things and think through things, communicate things. And that is an area that we are still missing in AI. This is something that, of course, people have been working on for decades. My own PhD work, there's a little snippet from my PhD thesis down there, was in that area. And I also worked on bringing together, believe it or not, I wrote a paper. I spent a memorable summer at the Intel AI lab. Intel used to have an AI lab back in 1990, 29 years ago. And I wrote a paper on bringing together neural networks with probabilistic systems. So there is a long road that is still in front of us in getting to really much better kinds of AI that we can work with. And then even beyond the sphere of AI, when I look at just the state of digital technology, we have seen great examples. There's 2 pictures of Ivan Sutherland's Sketchpad system that he built in 1962. In 1962, this was like 6 years before I was born, he was able to build, there is a picture where he is drawing these rivets And he is using this electronic pen to draw this outline of a rivet, and his system was interpreting that this guy is drawing a rivet, and the rivet has these physical properties. And he actually constructed a bridge using these things, and he demonstrated how you could do simulations on the bridge, load tests, and at what load the bridge would break, and so forth, in 1962. And inspired by his work, Doug Engelbart, of course, that's the other guy with the mouthpiece on, he did this demo of real-time collaboration and things like that, and that inspired Alan Kay, who is the gentleman in the red blazer that you see there, to come up with, that's the Dynabook that he is holding. In 1972, he already could see that a Dynabook-style computer could be made, and of course, the iPad came, I don't know, 37 years later or something. So we know how to build interactive, exploratory, real-time systems. We have seen this. These giants of our field have demonstrated how these things can be done. So clearly, we have an opportunity to do much better. And at a personal level, I was very fortunate 2 years ago, after I left my previous job, after 2 jobs leading very large organizations, I really had an opportunity to take a break and think about some of these issues and what I wanted to do and how can we address some of these issues. And going back to my own roots in AI and my time as a student, and how can we help bring better kinds of AI across the board to all businesses, and not only to all businesses, but to all aspects of a business. Doug Engelbart, I mentioned him earlier, he had this very nice metaphor when he thought about the real potential of digital technology, of real-time collaboration, of being able to interact with your computer, and so forth. He thought about organizations and these A processes, B processes, and C processes. And the idea basically was that the A processes are the products and services that we build, the things that we do. The B processes are those processes that help us make those A things, like HR and finance and operations and manufacturing and so forth. And the C processes are the longest-lived, most timeless kinds of processes. These are things like culture and education and training and so forth. And when you think about AI, you realize that we have an opportunity to bring AI to all of these, to all businesses, to A, B, and C processes of all of them. And can we build a platform that helps us get there? When you look at Facebook today, they use this AI technology with all the limitations that I talk about for hundreds of scenarios. There are literally thousands, perhaps tens of thousands of models running on several million computers built by a few thousand engineers running, I don't know, hundreds of applications for all kinds of things, from detecting fakes to fraud to facial recognition and who knows what else kinds of applications. And when you project that out forward, you realize that every business is going to build applications of this kind. So what does that platform look like that can help us build your next 100 AI-based applications? And can we also, as we are doing that, elevate the way that we do business? Bring an understanding of these techniques. And they are techniques. They are not dropping down from the sky. They are being built by, people like us. Can we help bring this scaling of educating people on these techniques to a massive number of people for the time that is ahead of us? I mean, 20,000 people can explain to you how convolutional neural networks work. That is out of 7 billion people on the planet. So that was our thinking, that how might we do these? How might we do this thing? I realized that I was saying all this without this slide behind me because I was looking at the next slide over here. So helping businesses achieve that, bringing AI to a massive scale, using a platform that can help us build those applications and achieve a large scale in education as well. And so that got us to the point where, with the help of Sanjay and Tao, and by the way, Sanjay is the genius who has made these beautiful visualizations, the flowers. The people backstage were asking me who made the flowers, and I said Sanjay did. We started YNI earlier this year. We want to build this kind of a next generation AI platform. We started building it last year. We want to bring it to life at enterprises through the power of design thinking. We also want to build AI applications, and we want to help education. So being a startup, we can dream big. When you hear about a lot of digital systems these days and how they have broken the trust of people, you realize that systems thinking is missing from the construction of a lot of these big systems that we use every day. And so what would it be like to bring systems thinking to the design and construction of thinking systems? And the heart of what we do is our platform. To start with, I mentioned earlier thinking fast and thinking slow, heterogeneous kinds of solvers, next generation kinds of AI work that is going to happen. But we really want to start with a platform that dramatically streamlines the experience of building AI systems, that encourages exploration and experimentation. It doesn't hide behind things like AutoML. It doesn't hide people saying, oh, you don't worry about the complexity. No, we want to go the other way. We want to get people to explore, to understand, to play with these systems, and to build systems that they can very accurately describe to you how they work, who understand what a marker is versus what a cancer is. And we have been working on creating an environment that brings data management, construction of features on data, understanding the phenomenon that underlie data that we are trying to predict with an intelligent system, and brings that in an environment that is integrated, meaning where business people, practitioners, and all these can come together and dramatically simplify both the expression and the execution of these systems. I started last year with plenty of free time looking into the details of this, and it gives me a headache every time I look at what an AI system today looks like. So enough talk. Let's show you what we have been working on. And to show this, I want to bring on stage Dan Amelang. Dan, come on over. This is Dan, ladies and gentlemen.
Good afternoon, everyone.
So Dan, I have talked about the fact that we can do better. Do you have something to show us?
Well, I think
first, can you show us how things are today?
that's right. Let's talk about the state of the art of development environments for data science and machine learning. And to do that, we should bring up Jupyter Notebooks. That is the most common environment. And Jupyter Notebooks were a step forward from traditional programming environments. They've empowered many data scientists and programmers. But we can do better. So let me first pull up an example of a Jupyter Notebook here.
Can we go to the
Almost there. So this is a real Jupyter Notebook. It was created by professional data scientists with real data from the Kaggle website. And the first thing you're going to notice...
Is that thing real?
Yeah, this is it. This is actual data science as it is right now. First thing you're going to notice is the complexity and the size of notebooks. There's a lot of code here, a lot of things that non-programmers might take for granted that are explicitly have to be coded here in Python, for example. You're also going to notice that all the data wrangling, the feature engineering, the model setup, the model training, the results, they're all in this one monolithic unit here.
So that whole thing is one experiment.
Yeah, this is one experiment for one particular project.
Wow.
Now, because of the nature of this, collaboration on notebooks it's very difficult because versioning is done at a very coarse-grained level. It's at the notebook level. And if I want to do any variations of feature engineering or variations on the model, it kind of leads to a lot of copy and pasting of code, and it gets very messy. We believe that For enterprise ML, what we really need is an environment that supports experimentation, not just programming. We need major advances in interactivity, explorability, and extensibility.
So that is what things are like today. So I have argued that we can do much better. So let's see what we can do better.
All right, well, let me introduce the ViNI platform. To demonstrate the platform, I'm going to dive into an existing ongoing project for customer retention. Here's the project overview. We can see the objective of the project. We can see the schedule, the people on the team. We can also see the data set that we're working with in the partition between training, validation, and test. And this is the most interesting part. We have
you have a friendly business analyst there.
That's right.
That's his better half, ladies and gentlemen.
I slipped in a picture of my wife there in the product. The success criteria is this is the place where we bridge the business objectives with the details of the ML system underneath, because enterprise ML projects are not created by single data scientists. They're created by cross-functional teams that include, say, business analysts or other stakeholders in the line of business. And this is where we bridge those two worlds.
This is a very important point, that AI helps us do problem solving, but the problem finding comes before that. And business people are the ones who give us that relevance, that strategic importance of what is it that is important, what are they looking for, what matters. And so a place where the AI and the data science can come together with the problem, with the business people, is incredibly important.
Yeah, for example, you could read at the top of the success criteria. It says, the model should predict membership cancellations, which are indicated in the will cancel column. I can go right down into my data set and find that column and see exactly where the data has been labeled. Or concepts like precision and recall can be broken down into plain English. When the model predicts membership cancellations, it must be correct 70% of the time. Makes sense. So now that we have an overview of the project, let's dive in and see how well it's going. So this is an overview of all the experiments that have been done on this project. I can browse them by going over the precision recall curve and see them getting highlighted. I can browse through and look at the features that were used in each experiment. I can see the models that were used in each experiment and the results from them.
So you could have dozens, if not hundreds, of experiments all in one place.
So that's the idea, is that for enterprise ML applications, it'll take weeks or months for the project to run its course. And during that time, people produce dozens, sometimes hundreds of experiments. And right now, we don't have any tools to help us manage them at this level. But as a data scientist, if I want to dive in and build on any of this work, I can easily do that right here. And I will. There's a experiment at the top that's pretty close to the project objectives. So I'm going to dive right in and see if there's something we can do to improve it.
Yep.
So I'm clicking on the results here, and it pulls up a deep dive into how this experiment went. There's a precision recall curve that I can scrub through for a given threshold. If I get around there, I see that I'm pretty close to my precision objectives here. Well, I've surpassed them. But on recall, I'm still not there yet. So I can look at the confusion matrix on the other side, and I see that, yeah, the false negatives, well, these are false negatives. We can see the true negatives, the false positives, and the true positives. And to improve my recall, I'm going to need to do something about those false negatives.
Can you see just those in the data?
That's exactly right. So below here, we have the validation data that was run on the model to generate these results. And I really want to just see those examples of the false negatives, the things I need to detect or predict better. So if I click on the false negative quadrant, then the validation data is filtered by false negative. And I can look it over, and this data comes from a national gym chain. And I have a feeling that something about the date that the people joined might have to do with their cancellations. So I'm going to dive into that. I'm going to plot date joined for my false negatives. And I can see that there's quite a spike there. That's in the month of January. This means that the people who join the gym in January are very likely to cancel a membership later in the year. may have something to do with New Year's resolutions. So with that insight, I'd like my model to be able to use that in its prediction. So
with this new feature that you added, did you add that feature yet or not yet?
I have not yet.
Okay.
But I think we have an idea of what we need to do. So within the same tool, I can go to the feature engineering page of the tool. This is what was already worked on previous to me making this variation of the experiment. I can see the training data now. I can see the features that were used previously. I can see what features were engineered here. I can even pull up the code that was used for each of the features that were engineered in the data set. And because we had this idea, I'm going to add a new feature here. I'm going to call it joined in January. And that adds a column to my data set here. You can see joined in January there. That's now something I can add as a feature to my experiment. And then I could train now, but I also want to look at this model. It looks like it's a little bit shallow, so let's dive into the...
You can edit the model itself right there.
I can. Let's go right in. And this is all building on the experiment that was there before. So here's my features coming into the model. This is the label. My predictions coming out. You can see this is a visual depiction of the neural network itself, but it's not just an illustration. I can actually manipulate this. I can add a fully connected layer. Should have an activation function. I'll choose logistic afterwards. Probably want to make that a little bit wider, bring it out to about there. And as you noticed on the right-hand side, along with the visual depiction of the architecture, I'm seeing some math on the right. That math is actually the implementation of each of these layers. It's not just an illustration. When this model is run, it is running basically executable math. I can go in myself and modify it if I wanted to, and that actually modifies the implementation of that particular layer. I'm going to restore it because I want this thing to train pretty well. So I think at this point, though, I'd like to see how well our experiment
So visual editing of the model, real-time exploratory, like Alan and Doug and Ivan showed.
That's it. All right, well then let's see how this does. I'm going to start at training. And if I go back to the list of experiments for the project, I see this variation has now been added to the top. It's replaced the previous version with my variation of it. And it just validated. And we see now that with that extra feature, it was able to pull up the recall to the point that now we've reached the project's objectives. It's very clear that that one passes what we wanted. We can see the new architecture there. And we can see the feature that we added. And we can browse the precision recall curve, the overlaid precision recall curve, and see that there's that little elbow in the corner that's getting us what we need for the particular project.
So this is awesome. So this is a complete, dramatic shrinking of the overall experience of building and managing and deploying AI models, involving the business people, the data scientists, the IT people, being able to go all the way down the rabbit hole to where the code is and implement that model. You skipped over something very interesting. You showed a language there, and you showed a visual representation of that language. Tell us more about that.
Well, what you saw there was really the core of our platform, which is a radically simplified programming model. What you saw there looks basically like mathematics. It is mathematics. We consider it executable mathematics. And it's able to radically simplify very complex systems. And if I may, I would like to show the capability of this language. I think, Vishal, earlier you showed some examples of the BERT language model being used.
Yes, all the squad leaders that I mentioned, most of them use this technique, this neural network model called BERT. Is that what you're going to show us?
Yeah. So BERT is a very complex, state-of-the-art neural network. It does natural language tasks. And it is, the reference implementation is implemented in Python using the TensorFlow library. Specifically, it's about 500 lines of Python code that then relies upon thousands and thousands of lines in the TensorFlow library. If you wanted to really understand how BERT works, you would have to dive in through all of that. In our system, using our executable mathematics, we're able to capture the entire BERT model, including the implementation of the layers, down to the mathematics in about 50 lines of code.
50 lines of code. And this math is implemented?
Yes, that's right.
So this is not just a specification. This is an implementation.
Yeah, we can consider it an executable specification, perhaps because it looks like a specification. It shows you everything you need to know about BERT, all the way down to the elementary mathematics. But then we can run it.
Can you show this thing running?
Sure. So let me go back to our list of projects here. This is our BERT project. This is the same mathematics that you saw earlier, but it's now within the system. And as I click on a different layer, then I can see the mathematics behind that particular layer in the network. And within this system, I can actually feed it some input here. One task that BERT can do is to fill in a blank in a sentence. Using the context of the sentence, it guesses what word should go there. So in this case, we're going to ask it what should go in this sentence. San Francisco is home to the blank gate bridge. And we'll see what it answers. So there we are. It's home to the Golden Gate Bridge. This output here was produced by our BERT model from those 50 lines of code that you saw earlier.
This is amazing. And I mentioned my PhD thesis earlier. This work that Dan has showed in the very end, this is related to his own PhD thesis, which hopefully, are you going to finish your PhD anytime soon, Dan?
I plan on it.
6 months, you think?
Spring 2020.
Dan Amelang, ladies and gentlemen. So that is our platform, a really dramatic simplification of the experience of building an AI system today with what we know. Real-time, exploratory, bringing together data scientists with business people, being able to go all the way down the rabbit hole to the math of the system, and learning from the great work that has happened in the history of our industry, making that math implementable. There is no reason why that math cannot be implementable. We know how to do that. And therefore, shrinking the entire ecosystem of what it takes to build an AI system. But earlier, I mentioned the other dimension of our work is working on real projects and with large enterprises. And earlier this year, we were very fortunate to work with one of the great enterprises of our time, Bank of New York Mellon. To talk about this, I want to call on stage Joe Sikowski. Joe, come on over. So Joe, you are the chief architect and the head of data at BNY Mellon. Tell us about BNY Mellon.
Well, yeah, BNY Mellon was founded by Alexander Hamilton. We're the bank of financial services institutions, corporations, governments, and high net worth individuals. Just to give everyone an idea of scale, we have about 1.8 trillion assets under management, 35 trillion assets under custody.
$35 trillion.
35 trillion assets under custody or administration, and about 250 billion in private wealth. At the bank, we have over 13,000 technologists and developers providing the critical technology to support our role in servicing those clients over the global financial markets. We innovate in-house, however, we partner when it makes sense with startups, fintechs, and established players.
Awesome.
And we're always looking for top technology and data science talent.
With 13,000 in-house people, BNY Mellon is one of the great, you're much further ahead on the AI journey. So tell us about your AI and machine learning journey.
Well, the way I think about machine learning, well, I believe that machine learning, AI, and data science is going to transform the enterprise. Regardless of your industry, effective firms are going to derive insights from data and drive actionable strategies to provide value for their customers and their stakeholders. But as Vishal talked about before, AI and ML isn't magic. It's complex and sophisticated math on data. And that means you need good due diligence, you need peer review, and you need good processes to ensure your models are actually effective and the underlying data is governed. We're using machine learning to essentially predict what we should know based on the data we have and our unique intellectual capital.
So tell us about the work that our teams have been doing. It has been an amazing experience, so tell us about that.
Well, we work together specifically on trying to predict fails in the securities market. Now, I have to kind of explain what that is to this larger audience, but essentially, we process trillions of dollars worth of security transactions daily. And what we call a fail is when one party fails to deliver securities to another party. And often the failing party has to pay interest and a penalty fee and stuff like that. Now, the amount of fails percentage-wise is very small.
But 2% of a few trillion is a few tens of billions of dollars.
It's a lot of money where one party would have to pay interest to another. Now, so we felt if we could predict these fails, we would not only provide for a more efficient market, it would allow us to be in a position to help our customers where we could loan a security or have a security available for that customer in the event they needed it. And that's what we had a successful outcome.
Successful outcome. That's all you can say about it?
No, it was a very successful outcome.
Awesome. No, it has been an amazing experience to work on being able to predict these failures. Any advice that you have based on what you have learned to the enterprises here?
Yeah, just some advice I'd give is when you're selecting a machine learning or AI problem, make sure you have a clear business objective. Make sure you actually have the underlying data. Time box yourself, 6 to 12 weeks for the analysis. But one thing I wanted to point out is I really view machine learning and AI as augmenting the human beings. It allows you to put your personnel on the really tough and higher level problems. Absolutely. It drives better decisions, puts your experts on those things they really need to focus on. And what I was saying inside the firm is, when you're looking for needles in a haystack, you want to hand your team magnets.
Absolutely. Joe Sikowski, ladies and gentlemen. Thanks, Joe. Yeah. So as Joe said, as you, as enterprises, think about bringing AI to life in your shops, in your houses, you have to find and engage with trusted partners to help. Can we go back one slide, please? To help accelerate that adoption, the activation of AI. We really have an opportunity to go from what we used to have as systems of record and later on the systems of engagement to building these brains, these minds inside the enterprise, these systems of intelligence. That will require, and Joe talked about this, an end-to-end perspective bringing together the business people, the domain experts, and the AI engineers and data scientists in a way that who are empowered to build these explorable, interpretable, transparent models that are simple, safe, easy to use, that we can rely on. I think that is the way AI will come to life in enterprises. And that's what we are focused on working. But we hear a lot about the bigger purpose. So as we embark on this journey, this would be a good moment to think about the bigger purpose. What is the bigger picture here? I mentioned Alan earlier, a great teacher of my life. Much of the personal computing that you see in your hands, in your lives today, is a result of this man more than perhaps anyone else. Can we play a little video? I asked Alan to think about this and tell us his thoughts. Can we play his video, please?
Thanks, Vishal. You asked me to talk about enterprises in the future and also about AI in the future, and could I do it in a 2-minute video? And my response was, oh, okay. Well, most of our favorite tools over the last 100,000 years extend the things we do. They amplify outwards. Doug Engelbart called these A tools and processes. They're used to further our goals. The feedback from these to improve the A tools and processes, Doug called B tools and processes. Most people in organizations are much stronger with A than B. A second kind of tool amplifies inwards. Here's a recent one from just 5,500 years ago. The little girl has her own goals for reading this book, but writing has its own agenda and starts doing things with her, and eventually changes her points of view and changes her goals, provides her with more perspectives and goals about what to do. So learning more ways to think about what we should do. These are the C tools and processes. Much of human progress in the world has come from the second kind of inward tools, and they require much more learning than the outward tools, but the rewards have been enormous. civilization itself. The kind of learning facilitated by the outwards tools is mostly in their terms, like hammering as an idea, and the larger idea of hammering things itself and making things like hammers. So maybe as an adult, this little girl might decide to use a nuclear weapon to hammer a problem. There are people like that. And we're already using machine learning and rudimentary AIs as hammers, and much of this is not helping things. But on the other side, the inward tool learning is teaching us new ways to think about things. And some of these will help us learn and use our tools and invent new tools better. So consider that the next stage that the book was one of the early starts of could be greatly facilitated by AI to help us learn inside our heads what we need to know. So consider how much more powerful AI could be to help our own C processes, the ones that actually judge what it is that we should be doing and how. Most modern tools amplify out. We need to add new tools that amplify in. Thank you very much.
Wow. Alan Kay, ladies and gentlemen. So, in conclusion, I think that we can all agree that there have been some impressive advances in AI. It is clearly a very powerful technique, a very powerful force that can help us across our businesses. But there are still significant issues that still remain. And the stack that we have today, the tools that we have today to work with, are far too fragmented, too asymmetric, too broken. We can do better. There is a massive opportunity to reimagine the developer experience, to bring the benefits of it to all of us. But as Alan said, and as Joe alluded to as well, the biggest opportunity is not just in understanding AI and in using AI, but in using it to better understand and amplify our own humanity, and bringing it to all that we do, including our businesses. We at YNI are really excited about this journey. We think we are on to a real breakthrough in how we might help dramatically accelerate the adoption of AI in the enterprise, and we would love to work with you, whether it is on our projects or on our platforms. Let's do something wonderful together. hello@yn.ai. Thank you very much.